Hi, I'm Kian, and today I want to show you how to find a gradient of a multivariable function. So, first of all, gradient is like a fancy word for derivative, but it's actually a derivative of a vector or like function that has more than one variable. So here we have f of x comma y comma z, which is a three-variable function. And this function is sine of x times y plus 2 times z times y plus z times x. And we want to find the gradient, or better said, like the derivative, at pi comma 2 comma 3. But taking the gradients requires us like to have some knowledge from partial derivative. So what should we do? So we have to do three steps. The first step, our first step to solve this question is to take the derivative of this whole function with respect to x. And then we can evaluate that and we can find the first point of the gradient. So if we want to take the partial derivative with respect to x, we can treat other variables, in this case y and z, as constants. For example, the derivative of sine x times y with respect to x, we can treat y as a constant. We can take this out of it. So let me write it. The partial derivative with respect to x. I'm not sure if I wrote the notation correct, but we'll see. So when we differentiate sine x times y, we can treat y as a constant. So I can take y outside of the derivative. Derivative of sine x is cosine x. And then I can bring the constant in front of and multiply it by cosine x. Cosine x times y. And then plus, and then for the next part of the function, we see that 2 times z times y. This has no x in it, so this is all constant. And derivative of a constant is just 0. So plus 0 doesn't matter. And then we have plus z times x. Again, we treat z as a constant because we're differentiating with respect to x. We take z outside of the derivative. Differentiating x, we get 1 times z, we get z. Now, when we evaluate this at pi comma 2 comma 3, pi comma 2 comma 3, so when we plug in, we should plug in pi for x, 2 for y, and then z, 3 for z. So, and then when we plug in, cosine of pi is negative 1 times 2, we get negative 2. And then plus z, which is plus 3, we get 1. But we're not done. We have found just the x component of our gradient. Now we should take the partial derivative with respect to our second variable, which is y. So I write it here. We should find the partial derivative with respect to y. And this is equal to, now we should treat x and z as a constant and y as a variable. So for example, when differentiating sine of x times y, we know that a sine of x, it has an x in it, so we can treat it as a constant. We can take this out of the derivative, and then differentiating y, we get 1, and then multiplying by sine x, we get just sine x. For the next part, we see that the next part of the function is plus 2 times z times y. Okay, then now we see that we can treat 2 times z as a constant. We can take this outside of the derivative. Differentiating y, we get 1 times 2z, we get just 2 times z. And then plus z times x has no y's, this is just a constant. Derivative of a constant is 0, so doesn't matter. And now when we evaluate this at pi comma 2 comma 3, okay, so sine of pi using the unit circle, we know that this is 0. Shoot a different color, 0. And then 2 times z, 2 times 3 is just 6. So the partial derivative with respect to y evaluated at this point is 6. Now, our last job is to find the partial derivative with respect to z, our last variable. Okay, so we come up here to our original function. So for the first part, sine of x times y, we see that there is no z components here. So we can treat sine of x and y as a constant, and derivative of a constant is 0. So it doesn't matter. The next part, 2 times z times y. Now we can take 2 times y outside of the derivative because we can treat it as a constant. Derivative of z is just 1. 2 times y is 2 times y times 1 is just 2 times y. And then plus z times x. So again, z times x, x is a constant. We can take this outside of the derivative. Differentiating z, we get 1 times x, we get plus x. And then we should evaluate this partial derivative at pi comma 2 comma 3. And when we evaluate it, we should put 2 times 2, which is 4, and then 4 plus pi, we get 4 plus pi as our partial derivative with respect to z at this point. So to sum up, the gradient of this function at this point is a vector actually, and it has 3 components. The x component is 1, comma, 6, then comma 4 plus pi. Thanks for watching. Please subscribe to my